What is Kubernetes?
Kubernetes, often abbreviated as Kubernetes, is an open-source container orchestration platform originally developed by Google and now maintained by the CNCF. It automates the deployment, scaling, and management of containerized applications across a cluster of machines, providing self-healing, load balancing, service discovery, storage orchestration, and declarative configuration management.
What problem does Kubernetes solve?
Kubernetes solves the operational challenges of running containers at scale. Before Kubernetes, teams had to manually schedule containers onto servers, handle failures, balance traffic, and manage configuration. Kubernetes automates all of this. It decides where to run containers, restarts failed ones, scales based on load, distributes traffic, and manages secrets and configuration, reducing operational burden dramatically.
What is a Kubernetes cluster?
A Kubernetes cluster is a set of machines, called nodes, that run containerized applications managed by Kubernetes. Every cluster has at least one control plane node that manages the cluster state, and one or more worker nodes that run the actual application workloads. The control plane exposes the Kubernetes API and makes global decisions about the cluster, such as scheduling.
What are the main components of the Kubernetes control plane?
The Kubernetes control plane consists of the API server, which is the front end for all cluster operations, etcd, the distributed key-value store that holds the cluster state, the scheduler, which assigns pods to nodes, the controller manager, which runs controller loops to maintain desired state, and the cloud controller manager, which integrates with cloud provider APIs for features like load balancers and volumes.
What is the Kubernetes API server?
The Kubernetes API server is the central management component that exposes the Kubernetes REST API. All interactions with the cluster go through it, whether from kube control, internal components, or external tools. It validates and processes API requests, stores the resulting state in etcd, and notifies other components of changes. It is the only component that directly reads from and writes to etcd.
What is etcd in Kubernetes?
etcd is a distributed, consistent key-value store used by Kubernetes as its backing store for all cluster data. It stores the entire cluster state, including pod definitions, secrets, config maps, node information, and more. etcd uses the Raft consensus algorithm to provide strong consistency and high availability. Backing up etcd regularly is critical for disaster recovery.
What is the Kubernetes scheduler?
The Kubernetes scheduler watches for newly created pods that have no assigned node and selects the best node for them to run on. It considers factors like resource requirements and availability, node affinity and anti-affinity rules, taints and tolerations, pod topology spread constraints, and data locality. It uses a two-phase process of filtering nodes that can run the pod, then scoring the remaining nodes.
What is the controller manager in Kubernetes?
The Kube Controller Manager runs a collection of controller loops that watch the cluster state and work to move the current state toward the desired state. Examples include the replication controller, which ensures the correct number of pod replicas exist, the node controller, which responds when nodes go offline, the endpoints controller, which manages endpoints objects, and the service account controller.
What is a Kubernetes node?
A node is a worker machine in Kubernetes, either a physical or virtual machine, that runs containerized workloads. Each node is managed by the control plane and runs three key components: the kubelet, which communicates with the API server and manages pods on the node; the kube proxy, which maintains network rules for pod communication; and a container runtime like containered to run the actual containers.
What is the kubelet?
The kubelet is an agent that runs on every worker node in the cluster. It receives pod spec objects from the IPI server and ensures the containers described in those specs are running and healthy. It reports node and pod status back to the control plane, manages container lifecycle, handles liveness and readiness probes, and interacts with the container runtime through the container runtime interface.
What is kubeproxy?
kubeproxy is a network proxy that runs on each node and implements the Kubernetes service concept. It maintains network rules using iptables, IPVS, or eBPF depending on configuration that allow network communication to pods from inside or outside the cluster. When a service is created, kubeproxy programs the nodes networking to route traffic for the service's virtual IP to the correct backend pods.
What is a pod in Kubernetes?
A pod is the smallest deployable unit in Kubernetes and represents a single instance of a running process. It encapsulates one or more containers that share the same network namespace, IP address, and storage volumes. Containers within a pod can communicate via localhost and share the same lifecycle. Pods are ephemeral. They are created, destroyed, and replaced rather than moved or repaired.
Why would you run multiple containers in a single pod?
Multiple containers in a pod are used when containers are tightly coupled and need to share resources. Common patterns include the sidecar pattern, where a helper container enhances the main container, such as a log shipper or proxy. The ambassador pattern, where a proxy handles external communication. And the adapter pattern, where a container transforms the main container's output. All containers in a pod start together and share the same IP and volumes.
What is a namespace in Kubernetes?
A namespace is a logical partition within a Kubernetes cluster that provides a mechanism to isolate groups of resources. They are useful for dividing cluster resources between multiple teams or applications. Resource names must be unique within a namespace, but not across namespaces. Kubernetes starts with default namespaces including default, kubesystem for cluster components, kubepublic for publicly readable resources, and kubenodeless for node heartbeats.
What are Kubernetes labels and selectors?
Labels are key value pairs attached to Kubernetes objects that are used to organize and identify resources. Selectors allow you to filter and select objects based on their labels. Services use label selectors to route traffic to matching pods. Deployments use label selectors to identify which pods they own. Labels and selectors are fundamental to how Kubernetes components discover and interact with each other.
What are Kubernetes annotations?
Annotations are key value pairs attached to Kubernetes objects, similar to labels, but they are not used for selection. They store arbitrary non-identifying metadata, such as build timestamps, git commit hashes, links to runbook URL-TKS, or configuration for tools like ingress controllers and monitoring agents. Unlike labels, annotation values can be large strings containing structured or unstructured data.
What is the difference between labels and annotations?
Labels are intended for identifying and selecting Kubernetes objects and have restrictions on character length and valid characters. Selectors use labels to filter objects, and Kubernetes components rely on them to identify owned resources. Annotations are for storing arbitrary metadata and have much more relaxed constraints on length and content. Annotations cannot be used in label selectors, so they do not affect how Kubernetes groups or selects resources.
What is a Kubernetes manifest?
A Kubernetes manifest is a YAML or JSON file that describes the desired state of a Kubernetes resource. It specifies the API version, kind, metadata including the name and namespace, and spec which defines the resource configuration. You apply manifests with kube-control apply, and Kubernetes works to make the current cluster state match the manifest. Manifests are the foundation of declarative infrastructure management.
What is the difference between imperative and declarative Kubernetes management?
Imperative management uses commands like kube-control run or kube-control create to tell Kubernetes what to do step by step. Declarative management uses manifests with kube-control apply to describe the desired state, and Kubernetes figures out how to achieve it. Declarative management is preferred for production because it enables version control, reproducibility, and idempotency. Applying the same manifest repeatedly yields the same result.
What is kube control?
Kube control is the official command line tool for interacting with a Kubernetes cluster. It communicates with the Kubernetes API server to create, read, update, and delete resources, view logs, execute commands in containers, manage contexts, and perform cluster operations. It reads its configuration, including cluster credentials and context, from the kube config file, typically located at ~kube/config.
What is a deployment in Kubernetes?
A deployment is a higher-level abstraction that manages a set of identical pods. It provides declarative updates, meaning you describe the desired state, and the deployment controller makes it happen. It handles rolling updates with configurable strategies, rollbacks to previous versions, scaling the number of replicas, and self-healing by replacing failed pods. Deployments are the standard way to run stateless applications.
What is a replica set?
A replica set ensures that a specified number of pod replicas are running at all times. If a pod fails or is deleted, the replica set creates a replacement. While replica sets can be used directly, they are typically managed by deployments, which add rolling update and rollback capabilities on top. You should generally use deployments instead of replica sets directly.
What rolling update strategies does a deployment support?
Kubernetes deployments support two update strategies. Rolling update, the default, gradually replaces old pods with new ones. The max unavailable parameter controls how many pods can be unavailable during the update, and max surge controls how many extra pods can exist above the desired count. Recreate terminates all existing pods before creating new ones, causing downtime but avoiding version mixing. Canary and blue-green patterns are built on top of these primitives.
How do you perform a rollback of a deployment?
You roll back a deployment using kube control rollout undo deployment /name, which reverts to the previous revision. You can roll back to a specific revision with the to-revision flag after checking the history with kube control rollout history. Kubernetes stores rollout history up to the revision history limit, which defaults to 10. Each rollout, whether forward or backward, is recorded as a new revision.
What is a stateful set in Kubernetes?
A stateful set manages the deployment and scaling of a set of pods, where each pod has a unique, persistent identity. Unlike deployments, stateful sets provide stable network identities with predictable pod names like app0 and app1. Stable storage with persistent volume claims that are retained if a pod is deleted. And ordered deployment and scaling where pods start and stop in sequence. Stateful sets are used for databases, message queues, and other stateful applications.
What is a daemon set in Kubernetes?
A daemon set ensures that a copy of a pod runs on all or a subset of nodes in the cluster. As nodes are added to the cluster, pods are automatically added to them. When nodes are removed, those pods are garbage collected. Daemon sets are commonly used for cluster-wide tasks like log collection agents, node monitoring agents, network plugins, and storage daemons that need to run on every node.
What is a job in Kubernetes?
A job creates one or more pods and ensures that a specified number of them successfully terminate. When a pod completes successfully, the job tracks the completion. Jobs are used for batch processing, one-time database migrations, data transformation tasks, and other finite workloads. You can control the level of parallelism with the parallelism field and the number of completions required with the completions field.
What is a cron job in Kubernetes?
A cron job creates jobs on a repeating schedule defined using standard cron syntax. It is the Kubernetes equivalent of a Unix cron job. Cron jobs are used for periodic tasks like backups, report generation, or sending notifications. You can control concurrency policy to forbid or allow concurrent job runs, configure the history of successful and failed jobs to retain, and set a starting deadline for missed schedules.
What is the difference between a deployment and a stateful set?
Deployments are for stateless applications where all pods are interchangeable. Pods have random names and no guaranteed storage persistence. Stateful sets are for stateful applications where each pod has a unique identity, a stable host name, and persistent storage that follows the pod through rescheduling. Stateful sets also provide ordered, sequential deployment and termination, whereas deployments can create and delete pods in any order.
What is an init container?
An init container is a specialized container that runs to completion before the main application containers in a pod start. Init containers always run to completion, and each must finish successfully before the next one starts. They are used for setup tasks like waiting for a dependent service to be ready, downloading configuration files, performing database migrations before the application starts, or setting up file permissions on shared volumes.
What are sidecar containers in Kubernetes?
Sidecar containers run alongside the main application container within the same pod, sharing its network and storage. They extend or enhance the main container without modifying it. Common sidecar use cases include log forwarding agents that ship logs to a centralized system, service mesh proxies like Envoy that handle traffic encryption and observability, configuration reloaders that watch for config changes, and OAuth proxy containers for authentication.
What is a pod disruption budget?
A pod disruption budget is a Kubernetes object that limits how many pods of an application can be simultaneously disrupted during voluntary operations like node drains, rolling updates, or cluster upgrades. You set either min available, a minimum number or percentage of pods that must remain running, or max unavailable, the maximum number that can be unavailable. PD beta protect availability during planned maintenance without affecting involuntary disruptions like node failures.
What is a horizontal pod autoscaler?
A horizontal pod autoscaler automatically scales the number of pod replicas in a deployment, replica set, or stateful set based on observed metrics. The most common metric is CPU utilization, but you can also scale on memory or custom metrics from external systems. The HPI controller periodically checks the metrics, computes the desired replica count, and adjusts the workload accordingly, with configurable minimum and maximum replica bounds.
What is a vertical pod autoscaler?
A vertical pod autoscaler automatically adjusts the CPU and memory resource requests and limits of containers based on actual usage observed over time. Unlike the HPI, which scales horizontally by adding pods, the VPI scales vertically by right-sizing individual pods. It can update pods immediately by evicting and restarting them with new resource settings, or operate in recommendation mode to suggest values without changing anything.
What are resource requests and limits in Kubernetes?
Resource requests are the amount of CPU and memory a container is guaranteed to receive. The scheduler uses requests to decide which node can fit a pod. Resource limits cap the maximum amount a container can consume. If a container exceeds its memory limit, it is killed and restarted. If it exceeds its CPU limit, it is throttled. Setting appropriate requests and limits is essential for fair resource sharing and preventing noisy neighbor problems.
What is a quality of service class in Kubernetes?
Kubernetes assigns a quality of service class to each pod based on resource requests and limits. Guaranteed pods have identical requests and limits set for all containers and are never evicted unless they exceed their limits. Burstable pods have requests set but limits that are higher or unset and can be evicted under memory pressure. Best effort pods have no requests or limits at all and are the first to be evicted under resource pressure.
What is a Kubernetes service?
A Kubernetes service is an abstraction that defines a stable network endpoint to access a set of pods. Since pods are ephemeral and their IP addresses change, a service provides a constant virtual IP address and DNS name that remains the same regardless of pod restarts. The service uses a label selector to identify its backend pods and distributes traffic among them, enabling reliable intracluster and external communication.
What are the types of Kubernetes services?
Kubernetes has 4 service types. Cluster IP, the default, exposes the service on an internal cluster IP only accessible within the cluster. Node port exposes the service on a static port on each node's IP, making it accessible externally. Load balancer provisions an external load balancer from the cloud provider. External name maps the service to a DNS name by returning a CNIME record, useful for accessing external services using internal service names.
What is a cluster IP service?
A cluster IP service exposes the application on an internal IP address within the cluster. This IP is reachable only from within the cluster, making it suitable for communication between internal services. Kubernetes automatically creates DNS records for cluster IP services, so pods can reach them by service name. This is the default service type and forms the backbone of internal microservice communication.
What is a node port service?
A node port service exposes the application on a static port between 30,000 and 32,767 by default on every node's IP address. External clients can access the service using any node's IP plus the node port. Kubernetes also creates a cluster IP service automatically. Node port is simple for development and testing, but not recommended for production because it requires clients to know node IP tickets and uses non-standard ports.
What is a load balancer service?
A load balancer service extends node port by additionally provisioning a cloud provider's external load balancer, such as an AWS, a LB, or GCP cloud load balancer, and pointing it at the nodes. The cloud load balancer's external IP is automatically assigned to the service. This is the standard way to expose services to the internet in managed cloud environments, though it creates one load balancer per service, which can be costly at scale.
What is an ingress in Kubernetes?
An ingress is a Kubernetes API object that manages external access to services within a cluster, typically HTTP and HTTPS. Unlike services, an ingress can route traffic to multiple backend services based on URL paths and host names, terminate TLS, and perform name-based virtual hosting, all through a single entry point. An ingress requires an ingress controller such as Nginx, Traefik, or the cloud provider-specific controller to function.
What is an ingress controller?
An ingress controller is a pod that runs in the cluster and implements the ingress API by watching for ingress resources and configuring a load balancer or proxy accordingly. Unlike most Kubernetes controllers, ingress controllers are not started by default. You must deploy one. Popular options include Ingress Engine X, Traefik, HA Proxy, Kong, and cloud-native options like a WS Load Balancer controller or GKE Ingress.
What is a network policy in Kubernetes?
A network policy is a Kubernetes resource that controls traffic flow at the IP and port level between pods or between pods and external endpoints. By default, pods accept traffic from any source. Applying a network policy selects specific pods using label selectors and defines which ingress and egress traffic is allowed. Network policies are implemented by the network plugin, CNI. So the cluster must use a CNI that supports network policies, such as Calico, Cilium, or Weave.
What is a CNI plugin in Kubernetes?
A container network interface plugin is software that implements networking for Kubernetes pods according to the CNI specification. Kubernetes uses the CNI to assign IP addresses to pods, set up network interfaces, and configure routing. Different CNI plugins offer different features. Flannel provides basic overlay networking, Calico supports network policies and BGP routing. Cilium offers eBPF-based networking with advanced security and observability, and Weave provides encrypted overlay networking.
What is Kubernetes DNS?
Kubernetes runs a cluster DNS service, typically core DNS, that automatically creates DNS records for services and pods. Services get a DNS name in the format service name namespace SVC cluster local. Pods get records based on their IP. This allows services to discover each other by name instead of hard-coded IP addresses. Core DNS is configurable and can be extended with plugins for custom DNS behavior.
What is a headless service?
A headless service is created by setting the cluster IP field to none, which disables the virtual IP allocation. Instead of a single stable IP, DNS queries for the service return the IP addresses of all matching pods directly. This gives clients direct access to individual pod IP tickets and is used with stateful sets so that each pod can be addressed individually. For example, pod 0, service namespace SVC cluster local, which is essential for databases and clustered applications.
What is an external name service?
An external name service maps a Kubernetes service to an external DNS name by returning a CNIME record when queried. No proxying occurs. The DNS response simply redirects clients to the external hostname. This is useful for abstracting external dependencies like a managed database or third-party IP behind an internal service name, allowing you to change the external endpoint without updating application configuration.
What is the difference between ingress and a load balancer service?
A load balancer service provisions one external load balancer per service, which is simple but expensive and wasteful at scale. An ingress uses a single entry point and routes traffic to multiple backend services based on rules like host names and URL paths, making it more efficient and cost-effective for HTTP workloads. Ingress also supports TLS termination and name-based virtual hosting natively. Non-HTTP services generally still require a load balancer type.
What is an endpoint in Kubernetes?
An endpoints object is automatically created and managed by Kubernetes for each service that uses label selectors. It stores the IP addresses and ports of all pods that match the service's selector and are currently ready. When traffic hits the service's cluster IP, kubeproxy reads the endpoints to route the traffic to a healthy backend pod. You can also manually create endpoints for services without selectors, such as when mapping to external resources.
What is endpoint slice in Kubernetes?
Endpoint slice is a scalable alternative to the endpoint's IP, introduced to address performance problems in large clusters. A single endpoints object can become very large for services with many pods, causing excessive updates and network traffic. Endpoint slice shards the endpoint information into multiple smaller objects with a configurable maximum size, defaulting to 100 endpoints per slice. This significantly reduces the data transmitted to each node when endpoints change.
What is a service mesh?
A service mesh is an infrastructure layer that handles service-to-service communication within a microservices application. It is typically implemented using sidecar proxies injected alongside each service pod. The mesh provides features like mutual TLS for encrypted and authenticated communication, traffic management with load balancing and circuit breaking, observability with metrics and distributed tracing, and fine-grained access control, all without changing application code. Istio, Linkerd, and Console Connect are popular options.
What is a persistent volume in Kubernetes?
A persistent volume is a piece of storage in the cluster that has been provisioned by an administrator or dynamically by a storage class. It is a cluster-level resource independent of any specific pod. Persistent volumes have a life cycle independent of any pod that uses them. When a pod is deleted, the PV can be retained, recycled, or deleted based on its reclaim policy. They abstract the underlying storage infrastructure from the application.
What is a persistent volume claim?
A persistent volume claim is a request for storage by a user. It is analogous to a pod requesting node resources. A PVC specifies the required storage size, access modes, and optionally a storage class. Kubernetes binds the PVC to a suitable persistent volume that satisfies the requirements. Pods then use the PVC as a volume, and the actual storage is transparent to the pod. PVC tickets allow users to consume abstract storage without knowing the underlying infrastructure details.
What are persistent volume access modes?
Access modes define how a persistent volume can be mounted. Read-write once means the volume can be mounted as read-write by a single node. Read-only many means the volume can be mounted as read-only by many nodes simultaneously. Read-write many means the volume can be mounted as read-write by many nodes simultaneously. Read-write once pod, added in Kubernetes 1.22, means the volume can be mounted as read-write by only a single pod. Not all storage backends support all access modes.
What is a storage class in Kubernetes?
A storage class provides a way to describe the types of storage available in a cluster and define how persistent volumes are dynamically provisioned. It specifies the provisioner, such as the WSEBSCSI driver, and parameters like disk type and replication factor. When a PVC requests a specific storage class, Kubernetes automatically creates a PV using that class's provisioner. Clusters typically have a default storage class used when a PVC does not specify one.
What is dynamic provisioning of persistent volumes?
Dynamic provisioning automatically creates persistent volumes on demand when a persistent volume claim is created, eliminating the need for cluster administrators to manually pre-provision storage. It works through storage classes, which define the provisioner and parameters. When a PVC referencing a storage class is created, the provisioner automatically creates the underlying storage resource, such as an WSEBS volume or GCP persistent disk, and binds it to the PVC.
What is the persistent volume reclaim policy?
The reclaim policy determines what happens to a persistent volume after its persistent volume claim is deleted. Retain keeps the PV and its data, but marks it as released, requiring manual cleanup before reuse. Delete automatically deletes both the PV object and the underlying storage asset, which is the default for dynamically provisioned volumes. Recycle is deprecated and should not be used. The reclaim policy is critical for protecting data from accidental deletion.
What is a config map?
A config map is a Kubernetes object for storing non-sensitive configuration data as key-value pairs. Applications can consume config maps as environment variables, command line arguments, or as files in a mounted volume. Config maps decouple configuration from container images, allowing you to run the same image in different environments with different configurations without rebuilding. They are not encrypted, so they should not be used for sensitive data.
What is a secret in Kubernetes?
A secret is a Kubernetes object for storing sensitive data such as passwords, OAuth tokens, and TLS certificates. Secrets are similar to config maps, but are base 64 encoded and treated with additional security consideration by the cluster. By default, Kubernetes secrets are stored unencrypted in etcd, so encryption at rest should be enabled and RBAC should restrict access. Pods can consume secrets as environment variables or mounted files.
What is the difference between a config map and a secret?
Both config maps and secrets store key-value data for use by pods, but secrets are intended for sensitive data. Secrets are base 64 encoded, which is not encryption, and the cluster can be configured to encrypt them at rest in etcd. Access to secrets can be restricted with RBAC, and Kubernetes avoids writing secret data to logs. Config maps are for non-sensitive configuration and have no such protections. Use secrets for passwords, tokens, and certificates.
What is the CSI, Container Storage Interface?
The Container Storage Interface is a standard IPI for exposing storage systems to containerized workloads on container orchestration platforms like Kubernetes. Storage vendors implement CSI drivers that Kubernetes uses to provision, attach, mount, and unmount volumes. CSI replaced in-tree volume plugins, which were built into the Kubernetes codebase, allowing storage vendors to develop and ship drivers independently of Kubernetes release cycles. Examples include the WSEB SCSI driver and the GCEPD CSI driver.
What are empty dire volumes?
An empty dire volume is created when a pod is assigned to a node and exists as long as the pod runs on that node. Initially empty, all containers in the pod can read from and write to the same empty dire volume. The volume is deleted permanently when the pod is removed. Empty dire is useful for scratch space, sharing files between containers in the same pod, caching, and checkpointing long computations. It can optionally use memory as its backing medium.
What are host path volumes?
A host path volume mounts a file or directory from the host node's file system into a pod. It is useful for applications that need access to Docker internals or node-level monitoring tools. However, host path volumes are a security risk because they can expose sensitive host directories to pods, and pods with host path volumes are bound to specific nodes, breaking portability. They should be avoided in production and replaced with proper storage solutions where possible.
What is volume snapshot in Kubernetes?
Volume snapshots are a standard IPI for creating point-in-time copies of persistent volumes, similar to how persistent volumes and persistent volume claims work for storage provisioning. Volume snapshot resources represent a snapshot taken from a PVC. Volume snapshot content is the actual snapshot. Volume snapshot class defines the snapshot provisioner. Snapshots can be used for backups and to provision new volumes pre-populated with snapshot data using a data source in a PVC.
What is RBAC in Kubernetes?
Role-based access control is a mechanism for regulating access to Kubernetes resources based on the roles of individual users or service accounts. RBAC uses four main objects. Roles and cluster roles define a set of permissions. Role bindings and cluster role bindings grant those permissions to users, groups, or service accounts. Roles are namespace scoped, while cluster roles apply across the entire cluster. RBAC is the recommended authorization mechanism for Kubernetes.
What is the difference between a role and a cluster role?
A role is namespace scoped and grants permissions to resources within a specific namespace. A cluster role is cluster scoped and can grant permissions to cluster-wide resources like nodes, namespaces, and persistent volumes, as well as namespaced resources across all namespaces. You can bind a cluster role to a namespace using a role binding, which grants the permissions of the cluster role, but only within that namespace. Cluster roles are also used to define reusable roles that apply across multiple namespaces.
What is a service account in Kubernetes?
A service account provides an identity for processes running in pods to interact with the Kubernetes API. Every namespace has a default service account, and pods are automatically assigned to it unless specified otherwise. Kubernetes automatically mounts a service account token into pods, allowing them to authenticate with the API server. You should create dedicated service accounts for your applications with minimal permissions, following the principle of least privilege.
What are pod security standards in Kubernetes?
Pod security standards define 3 security policy levels for pods. Privileged applies no restrictions and is suitable for system-level workloads. Baseline prevents known privilege escalations and is a good starting point for most workloads. Restricted heavily restricts pod access and follows security best practices, requiring pods to run as non-root and use read-only root file systems. These standards replace the deprecated pod security policy and are enforced through the pod security admission controller.
What is a pod security admission controller?
The pod security admission controller enforces pod security standards at the namespace level. You label namespaces to specify which security standard to apply and the enforcement mode. Enforce mode rejects pods that violate the policy. Audit mode logs violations but allows pods to run. Warn mode generates warning messages but allows pods to run. A namespace can have different modes for different standards, allowing gradual policy enforcement during migration.
What is the principle of least privilege in Kubernetes?
The principle of least privilege means granting only the minimum permissions necessary for a subject to perform its function. In Kubernetes, this means creating dedicated service accounts for each application with only the RBAC permissions they need, avoiding the use of the default service account. Not mounting service account tokens if the application does not use the API. Running containers as non-root users, using read-only root file systems, and minimizing Linux capabilities.
How do you secure communication in a Kubernetes cluster?
Kubernetes secures communication through TLS certificates for all control plane component communication and between the API server and kubelets. etcd should use client certificate authentication and encrypt data at rest. RBAC should restrict API access. Network policies enforce pod-to-pod traffic restrictions. Service meshes can add mutual TLS between application services. Secrets should be encrypted at rest, and image scanning should ensure container images are free of vulnerabilities.
What is OP, a gatekeeper in Kubernetes?
OP, a gatekeeper, is a policy controller for Kubernetes that uses Open Policy Agent to enforce custom policies on API requests. It runs as an admission webhook and evaluates incoming API requests against user-defined constraint templates and constraints written in Rego. Gatekeeper allows you to enforce policies like requiring specific labels, limiting container images to approved registries, enforcing resource limits, or requiring security contexts, beyond what built-in admission controllers support.
What are admission controllers in Kubernetes?
Admission controllers are plugins that intercept API requests to the Kubernetes API server after authentication and authorization, but before the object is persisted to etcd. They can validate requests and reject them, or mutate them to set default values. Examples include Limit Ranger, which enforces default resource limits, Namespace Lifecycle, which prevents creating resources in terminating namespaces, and Pod Security, which enforces pod security standards. There are also dynamic admission controllers implemented as webhooks.
What are mutating and validating admission webhooks?
Mutating admission webhooks are called early in the admission chain and can modify objects as they are created or updated, for example, to inject sidecar containers or set default fields. Validating admission webhooks are called later and can only accept or reject requests without modifying them. Both are configured through mutating webhook configuration and validating webhook configuration resources, specifying which API resources and operations trigger the webhook call to an external HTTPS endpoint.
What is Kubernetes secret encryption at rest?
By default, Kubernetes stores secrets in etcd unencrypted, protected only by RBAC. To enable encryption at rest, you configure an encryption configuration file for the API server that specifies encryption providers and keys. Providers include IESCBC, IESGCM, and KMS for using external key management systems like a WSKMS, Azure Key Vault, or HashiCorp Vault. After enabling encryption, you must re-encrypt existing secrets by rerunning kubectl get secrets all namespaces and updating them.
What are image pull secrets in Kubernetes?
Image pull secrets are Kubernetes secrets containing credentials to authenticate with private container registries when pulling images. You create a secret of type kubernetesio/dockerconfig containing the registry credentials, then reference it in a pod's image pull secrets field or in the service account used by the pod. Without the correct pull secret, image pulls from private registries will fail with an authorization error.
How does the Kubernetes scheduler work?
The Kubernetes scheduler watches for unscheduled pods and selects a suitable node for each. It uses a two-phase process. In the filtering phase, it eliminates nodes that cannot run the pod based on resource availability, node selectors, affinity rules, taints, and topology constraints. In the scoring phase, it ranks the remaining nodes using scoring functions and assigns the pod to the highest scoring node. You can extend the scheduler with custom plugins or run additional schedulers alongside the default one.
What are taints and tolerations?
Taints are applied to nodes to repel pods. A node with a taint will not accept pods unless the pod has a matching toleration. Tolerations are applied to pods to allow them to be scheduled on tainted nodes. Taints have three effects. No schedule prevents new pods without a toleration from being scheduled there. Prefer no schedule tries to avoid scheduling there, but does not guarantee it. And no execute evicts existing pods that do not tolerate the taint. Taints and tolerations are used to dedicate nodes or handle node conditions.
What is node affinity in Kubernetes?
Node affinity is a set of rules used by the scheduler to determine which nodes a pod can be placed on, based on node labels. Required during scheduling, ignored during execution, is a hard requirement. The pod will not be scheduled if no matching nodes exist. Preferred during scheduling, ignored during execution, is a soft preference. The scheduler tries to find a matching node, but still schedules the pod elsewhere if it cannot. Node affinity is more expressive than the older node selector field.
What is pod affinity and anti-affinity?
Pod affinity and anti-affinity are rules that control how pods are scheduled relative to other pods based on their labels. Pod affinity attracts pods to nodes where certain other pods are already running. For example, co-locating a web application and its cache on the same node. Pod anti-affinity repels pods from nodes where certain other pods run, for example, spreading replicas of the same application across different nodes or availability zones for high availability.
What are topology spread constraints?
Topology spread constraints control how pods are spread across failure domains, such as zones, regions, and nodes. You specify the topology key, like topology Kubernetes EO/zone, and the max skew, which is the maximum allowed difference in the number of matching pods between any two topology domains. This ensures high availability by preventing all replicas from landing in a single zone or node, without using the more complex pod anti-affinity rules.
What is a priority class in Kubernetes?
A priority class defines a mapping between priority names and their integer values. Pods reference a priority class to indicate their scheduling and eviction priority. Higher priority pods are scheduled before lower priority ones when resources are limited. If insufficient resources exist, the scheduler may preempt or evict lower priority pods to make room for higher priority ones. Built-in system classes like System Cluster Critical and System Node Critical protect critical cluster components.
What is node selector in Kubernetes?
Node selector is the simplest form of node selection constraint. You add labels to nodes and then specify the same labels in a pod's node selector field. The scheduler only places the pod on nodes that have all the specified labels. While simple and easy to use, node selector only supports exact equality matching. For more expressive rules, including OR conditions and an equality, node affinity should be used instead.